Hi, this is CAD/CAM Lessons channel. In this video, I will show you how to get started with FreeCAD. FreeCAD is a truly free 3D CAD system where you can create your own 3D models, among others, for 3D printing. A huge advantage of FreeCAD is that you just need to download and install it. We don't have to register anywhere, we don't have to create an account, we don't have to provide our data. You just download it, install it, and you can start creating your own 3D models. To download FreeCAD, go to freecad.org, click the Download Now button, and choose the installation version for the system you are using, whether it is Windows, Mac, or Linux. Select the appropriate version, download it, and install. Regarding the version for Windows, we also have a version that does not require installation. Just download the archive, unpack it, and run the file freecad.exe from the bin folder. The installation of FreeCAD proceeds as standard. After downloading FreeCAD, it will start with the initial window. You may see a window like this. Here we define the unit system and navigation style. For the unit system, select Standard, and for the navigation system, select Blender. You can also choose a light or dark theme. Personally, I use the classic theme, which is not available here, but you can select this theme in Preferences. Now, when you go to the Edit menu and Preferences, the drop-down menu bar is not visible in my recording, but when we select Edit and Preferences, or on Mac, click the FreeCAD menu and select Preferences, we go to the FreeCAD Preferences. As for the theme, I use the classic theme. Here you also have a dark theme and a light theme. As for the operation of FreeCAD, with each theme, FreeCAD should work the same way, but there may be slight differences in the appearance of the menus. That's not a problem either, because we can customize the menu. I will show you in a moment how to do that. But now we will start creating a new project as a parametric part. Click this parametric part button, or select the part design module and choose a new file. We will create a 3D model in the part design module because in this module we work in such a way that we create 2D sketches on the basis of which we create a 3D model. We will make a simple 3D model, a very simple organizer, and now let's see how it looks. I don't think I changed anything here, and this is the menu I have by default after installing FreeCAD. If you would like to change something here, by grabbing those dots, you can move the icon bar. If any icon bar is not visible, right-click, and these options correspond to the icon bars. As for these commands, they are also available in the drop-down menu. As I mentioned, the drop-down menu bar is not visible in the recording, but now I am expanding the part design menu, where you have commands for creating 3D solids. At first, it may take some time to get used to the FreeCAD interface, but I think it just takes a few hours of learning, and after those few hours, you will be able to create your own 3D models. Now we will start creating such a model. In the part design module, we work in such a way that we create a 2D sketch, and based on that 2D sketch, we create a 3D model. We can create such a 3D model in stages. We can make a simple sketch, and based on the simple sketch, we create a solid by extruding the sketch. In the next stages, we can, for example, remove material from this solid. To create a sketch, click the Create Sketch icon, and here we have the basic coordinate system planes. We will select one of these planes as the sketch plane. Select the XY plane. This is the plane that defines the top view. Just click on this plane with the left mouse button. Note that we have been switched to the Sketcher module. In this module, we create two-dimensional sketches, on the basis of which we will then create a three-dimensional solid in the part design module. Here, I will simply create a regular rectangle. To do this, I select the rectangle drawing tool, and for the first corner of the rectangle, I choose the origin of the coordinate system. Note that when I hover my cursor near this point, that point is highlighted. I click with the left mouse button in this place when that point is highlighted, and by doing so, we have linked the corner of the rectangle to the origin point of the coordinate system. Now we define the dimensions of the rectangle along the x-axis, that is, along the red axis. The red color defines the x-axis, and along the y-axis, that is, along the green axis, we define the dimensions of the rectangle. There is also a blue color which defines the z-axis. However, in this view, the z-axis is not visible because we are looking at this sketch from the top. To define the dimensions of this rectangle, we can do it right at the sketching stage. I will enter the appropriate values. Initially, I will enter here a value of 70 for the x-axis and 50 for the y-axis. I will probably change these values later, because this is the preliminary shape of the box. In the next stage of 3D modeling, I will create 3 such pockets for various items, and in the end, I will adjust the dimensions of this rectangle. As for 3D modeling in FreeCAD, we have the ability to make changes at individual stages of sketching. If we create something, dimension it, it doesn't mean that it is the final dimension. Even when we have finished the project, we can go back to a previous stage and change the dimensions. Now I will close this sketch. Based on this sketch, we will create a 3D solid, and we will do this by extruding the sketch to a certain value using the pad operation. Select this operation, and as you can see, a solid has appeared in the preview. Here we define the height of this solid. Enter 20 mm as the height of this solid. If you click the left mouse button next to this field, the view will be updated. We click OK. This way, we have created a simple solid. It is just a regular cuboid, nothing special, but we already have a solid from which we can work. In the next stage, we will remove material from this solid. As for creating sketches, besides the fact that we can create sketches on the basic planes of the coordinate system, we can also create a sketch on the faces of the model. To create a sketch on the face of the model, click on that face with the left mouse button to select that face, and choose to create a sketch. Now this face becomes the sketch plane. Here I will create 3 pockets. We will also use the rectangle drawing command. Select this command and place the first corner of the rectangle roughly here. Regarding the dimensions of this rectangle, we will enter 15 mm for the x-axis. I press Tab to switch to dimensioning along the y-axis, and for the y-axis, I will enter 40 mm here. I press Enter. The rectangle drawing command is still active, so we can create more rectangles. I will create another rectangle whose first corner will lie at this point. Here, I will create a rectangle with dimensions of 20 by 40 mm. The rectangle command is still active, so we will now create another rectangle. This time we will create a rectangle that will lie roughly here, and we will create a rectangle with dimensions of 23 by 13 mm. We have 3 such rectangles. The rectangle drawing command is still active, but I don't need more rectangles, so I will cancel the rectangle drawing command. To cancel the rectangle drawing command or any other command in the sketcher, press the escape key or right-click in the workspace. Now that command has been cancelled. As you can see, we have created 3 rectangles here. These rectangles are dimensioned. I cannot change the dimensions of this rectangle. We can also draw rectangles in such a way that we don't have to specify the dimensions while drawing the geometry, and this rectangle was not dimensioned, and I can freely change the shape and position of this rectangle. Now I will delete this rectangle. To delete some geometry in the sketcher, we press the left mouse button and drag the selection box over the geometry we want to delete, or we simply click with the left mouse button on the geometry we want to delete. We don't have to press the Shift key or the Control key here. You just select the geometry you want to delete with the left mouse button and press Delete. The rectangles are dimensioned, but their position is not defined. Regarding defining the position of geometry in the sketcher, we can define the position of geometry relative to the origin of the coordinate system or relative to another geometry. To define the position of geometry, to define relations between geometries, we use constraints, and such constraints include dimensions that specify specific distances between geometries. To define the distance from this point to that point, we select these 2 points. We can select just this one point and choose dimensioning. Here you have the dimension command. If you expand this command, you have other commands here. This first dimension command is a general command that automatically selects the dimension to the selected geometry. If you want to use a specific dimension, you can use these individual dimensions. In most cases, this general dimensioning works. As you can see, I had this point selected and pressed the dimension command. Here the distance between these points has been automatically selected, but I would like to add the distance from this point to that point along the x-axis. As you can see, when I hover the cursor in such a way as to define the distance from this point to the origin of the coordinate system along the x-axis, that dimension will be selected. I click the left mouse button to specify that I want to add this dimension here. I enter 3 mm and press Enter. The dimension command is still active, so I click this point, and now I will define the distance from this point to the origin of the coordinate system along the y-axis. I hover the cursor in this direction, click the left mouse button, and enter 3 mm as the dimension value. What you can notice is that the color of this rectangle has changed to green. This indicates that this geometry is now fully constrained. Fully constrained geometry is such that we cannot change it freely. We cannot change the shape and position of this geometry by grabbing any vertex or any point of this geometry. Here, dimensioning was active, so I press Escape, and a dimension has been added here, and therefore we have an error caused by redundant constraint. Now I select this point again and define the dimension along the y-axis. I enter 3 mm and press Escape to cancel the dimensioning. Now the dimensioning is no longer active. As for fully constrained geometry, note that I try to grab this geometry with the left mouse button, and I cannot do that because this geometry is fully constrained. This means that its dimensions and position are already fully defined, and we cannot change it freely. As for these rectangles, they are dimensioned, but the position of these rectangles is not defined yet. Now we will proceed to define the position of these rectangles. For this rectangle, I would like to do it in such a way that this point lies at the height of that point. I select these 2 points and choose the horizontal vertical constraint, which states that these points will lie in a horizontal or vertical line. We can also expand these constraints, and we have the constrain horizontal and constrain vertical. In this case, we are defining it so that the line or 2 points are horizontal. By choosing the constrain vertical constraint, we define it so that the line or 2 points are in a vertical line. In the case of this constrain horizontal vertical constraint, one of these 2 constraints will apply, and I will apply the constraint to which it is closer. If these 2 points are almost in a horizontal line, then by selecting this constraint, it will automatically apply the constraint stating that these 2 points are in a horizontal line. I select these 2 points again and press the D key to activate dimensioning. Here another dimension has appeared, and I will specify the distance between these 2 points. I click with the left mouse button and enter 3 mm as the dimension value, and I press Enter. Now we will also define the position of this rectangle. I am changing the concept a bit. I will place this rectangle here, and we will do it similarly as in this case. We will apply a constraint between these 2 points. I select these 2 points and choose the constrain horizontal vertical constraint to define that these 2 points lie in a horizontal line. Next, I select these 2 points and press the D key on the keyboard to specify the distance between these points. Here, I enter 3 mm and press Enter. I'll create another rectangle, something like this. And now I'll add constraints to determine the dimensions and position of this rectangle. Here I will add an equality constraint specifying that the selected lines are equal. One line was dimensioned and the other line, due to the constraint, has the same length. Let's add more constraints. First, select these 2 points and add a vertical constraint here. Then select these 2 points and add a horizontal constraint here. Now we need to define the length of this rectangle side. We can do this by simply defining the distance between these points. Select these 2 points and enter 3 mm as the dimension value. I have created such a sketch, and based on this sketch we will remove material from this solid. I will close the sketch. But before we do that, I will go back to the first sketch and change the dimensions of the rectangle based on which this cuboid was created. As for creating a 3D model, as I have already said, we create the model based on sketches and then add operations to create 3D solids. Everything appears here in the history of 3D model creation, that is, in the feature tree. As you can see, we have here the sketch that we created, and we have the pad operation based on which this solid was created. However, the sketch that was used for this operation is not visible here. The fact that it is not visible doesn't mean that this sketch is not here. This sketch is simply inside the pad operation. If you expand this operation, you have this sketch, and this sketch is inside this operation. This sketch is not visible, but we can edit it. To edit the sketch, we click here twice with the left mouse button or right click and select Edit Sketch. Now we can change the dimensions of this sketch. Here, in this case, I want to change only this dimension. To change the dimension of the sketch, double-click with the left mouse button on the dimension you want to change and enter the new dimension value. We click OK, close the sketch, and as you can see, after making changes to the sketch, the changes were also applied to the model. Now, based on this sketch of the rectangles, we will remove material from this solid using the pocket operation. Select the sketch, choose the pocket operation, and as you can see, material has been removed from this solid. Here we define the depth of this pocket. Enter 17 mm as the depth of this pocket and click OK. In this way, we created a simple solid. One more important thing, when it comes to 3D design in various 3D CAD systems, it is advisable to save such projects. We do this in the standard way. From the File menu, we choose Save As, or simply click this icon and save the file on the disk. And if you want to use such a model for 3D printing, you need to export it to the STEP format or to the STL format. Currently, slicers support the STEP format, and I feel that this is a better format for exporting files because the STL format is a mesh of triangles. When it comes to making any edits to such a triangle mesh, it is quite a cumbersome process. The STEP format is a format in which the solid is saved. When it comes to editing such a solid, it is much easier than editing a model that is saved in an STL file, so if your slicer supports STEP files, and usually slicers used for hobbyist 3D printing support the STEP format, I suggest exporting models to this format. To export the 3D model we created in FreeCAD to the STEP format, we select this model. This model must be highlighted. Usually in FreeCAD we can do this by selecting the last operation or selecting body, and this model is highlighted in green here. Now we can export this model to the STEP format. To do this, from the File menu we choose Export. Then we specify the file name, the location where we will save this file, and we define the file format. We can choose among others the STL format, but as I mentioned, the STEP format should usually be a better choice. We click Save. Then we specify the export settings. Regarding these settings, at this stage of learning FreeCAD and exporting files to the STEP format, it doesn't matter much. Pay attention to the units and click OK. This model has been exported to the STEP format. Based on such a 3D model, we will prepare for 3D printing. Now I will show you how to prepare a program for the 3D printer based on the 3D model we created. I will do this in Bambu Studio software, which generates programs for Bambu printers. I use the A1 printer with AMS. We select the printer for which we want to prepare the machining program. By clicking this icon, we can add printers to the list. As you can see, I have added the Bambu Lab A1 printer here with a 0.4, 0.2 and 0.6 nozzle. I also have the Ender 3 S1 Pro printer added to this list, and I will add the Prusa Mini printer. I click Confirm, and here this printer has been added to the list. However, I will be preparing the program for the Bambu Lab A1 printer, so I select this printer. Here, I select the type of surface on which I will be printing. I have a plate that is the default supplied with the printer. It is a textured plate, so I will select this plate. Regarding filaments, as I mentioned, I use AMS and I have specified 4 colors and 4 materials that I use. By clicking plus, we add another filament to the list, and by clicking minus, we remove a filament from the list. Now, by clicking this square with the color, we specify the color of the filament. Here, by expanding this list, we select the print settings for this filament. As you can see on this list, I have 2 system presets for PLA and for PETG. The generic presets, whether for PLA or for PETG, you can choose to use filaments from manufacturers whose profiles are not included in Bambu Studio. By clicking this icon, you can change the print parameters for this filament. In some cases, it may be helpful to change the filament flow. Here, I have a coefficient of 0.95. If, for example, the printer is feeding too much filament or too little, we can make such a small adjustment here. In the next stage of working with the 3D printer, it's worth paying attention to temperatures. But for now, I will leave the default temperatures. I will also leave the default print parameters that Bambu Studio has prepared for the PETG material. When it comes to materials from other manufacturers, by clicking this icon, you can add other materials. Here we have a list of all filaments. Most of them are bamboo filaments, and then we have filaments with general parameters, and we also have several other manufacturers here. However, I don't use bamboo filaments. I use filaments from other manufacturers, and I mainly print with PLA or PETG, so I have chosen these general parameters for PLA and PETG here. In many cases, I simply use these default parameters and don't change anything here. Now we select the material we are using. I currently have PLA in red color mounted in this AMS slot, so I will leave this color, but I changed the type of material from PETG to PLA. Next, we select the print parameters related to the technical aspect of this print. Here we specify filament parameters mainly related to flow or temperature of the filament, and here we define parameters such as layer height, number of layers, or percentage of infill. We have several system predefined settings here. In the early stages of working with Bambu Studio, you can use the default settings. Here, I will choose the extra draft setting, and here it looks like the first layer is printed at a height of 0.2 and the other layers have a value of 0.28. Here we have parameters defining line width, but I will leave them as default. Now I go to the next tab. What might be useful in some cases is changing the number of walls. We have here the wall loops parameter. For now, I will leave it at 2, and the number of top layers can also be useful, as well as the number of bottom layers. We have 4 top layers and 3 bottom layers. These are layers that will be printed with 100% fill, so they will be just full layers. And here we specify the percentage of infill and the type of infill. As you can see, we have various types of infill. I will leave this as default for now. I will now add the model we created in FreeCAD to the project. To add the model to the project in Bambu Studio, we click the Add button. Here, we specify this model and click Open. I import it with the default parameters. I click OK, and what we created in FreeCAD has been imported into Bambu Studio. It has been imported in black. By default, everything we import into Bambu Studio, the models we import, are set as models that will be printed with the first filament from the list. If you would like to print this model with another filament, go to the Objects tab here and change the type of filament. Click here and a window will appear for selecting the filament. Here you can change the color and type of filament. I will go back to this filament because I want to print this box with PETG material. Now I will go to the Global tab and focus now on the number of walls. I currently have 2 walls set here. I go to the project preview and note how it looks. We will immediately discuss the number of top layers. Now I slide this down by 1 layer. See, we have 72 layers here. I slide it down by one layer. We are on the 71st layer, and here we have full infill. I go down to the 70th layer. We also have full infill because we have 4 top layers. I go lower, and we are already below these 4 top layers. Here we have an infill of 15% in a grid pattern. If we now change the pattern to another one, for example this one, we go back to the Prepare, Preview tab, and the infill type has changed. We can leave this infill. As for the number of walls, we have 2 walls here. Note that we have just created 2 walls of the solid. This may be sufficient in this case, but now if I change it to 3 and go to Prepare, Preview, we now have 3 walls. I will go back to 2 walls because in this model I don't need 3 walls. Now we will proceed to the bottom layers, and we will go all the way down. On the first layer we have full infill. Then the second layer also full infill. The third layer is also full infill. And on the fourth layer we start printing with 15% infill. So step by step you can see how it looks. And so we have the program ready for the 3D printer. As for the default parameters, I only changed the type of infill. However, in this case, in this project it doesn't matter much because it is just a regular box, so it won't be subjected to any loads. It will just stand there, so in this case it doesn't really matter. I will return to what was before to simply print this box with the default parameters. Now we need to generate the machining program for the 3D printer. When it comes to Bambu printers, you can do this in a few different ways. You can send the program directly from Bambu Studio to the 3D printer, but I use a memory card and simply save the programs on the memory card. Therefore, I choose the Export Plate Sliced File option. And now when I click this icon, we define the name and location of the file, save this file, and transfer this file on the memory card to the printer. On the printer we start the print, and I'll show it to you now.